Hey guys, this is Praveen, and in this video we're gonna see about implementation of linked list using Python. I already uploaded a video about linked list implementation, but because of some audio issues, I re-uploaded this. So this might help you. So you can see the comments here. Basically, the node is we want to create a node class, and we want to create a linked list class, and these are the methods in that linked list class. So let's come create it. So I typed it uh, without wasting any time. So this is the class node. This is a syntax for creating a class. So node is something which we call element in array. So in array we call it as element, and in linked list we call it as node. That every node contains a data that may be integer, that may be of any data type as required. And we have an init class, dunder init class. Basically dunder means the double underscore, which means dunder methods. Those are magical methods in Python. Let's make another video for this. So it contains self is something the object instantiation, which we call this as in Java. And we have data, and initially it is set to none. And we have next, which is a node which is initially set to none, uh, which means if we haven't given any next nodes or next data, it will set it to as none default by default. So self dot data is equal to data, the instantiation of object. And let us create linked list class. So I created a linked list class using the same syntax, and this is init method of the linked list class, and it contains self without any parameters initially, because as we see here, node will require two parameters, basically data and the next node's address. So it is set here, but initially the linked list requires no data for instantiation. And here the head of the linked list is being represented, and the size of the linked list being maintained, so that if we add an element we just increment it by 1, and if we remove an element we just decrement it by 1, so that the size is maintainable and we can produce size in constant time. So the next method is add last, which is similar to append method in um, list. So let me do it. So basically what we are doing here is we are adding an element to last of the linked list, to end of an linked list, whatever may be. And it contains a data, because we are adding an element, so it requires parameter, it requires argument data, a single data, which may be integer or any data type we want. And self dot size will add up to 1, because we are adding an element, so we must increment it by 1. And self dot data, that means we have to check if the linked list is none. So if the linked list is none, like if it is empty, though we are adding the first element to the linked list, so it's the head of the linked list, right? So this data could be the head of the linked list. So we are creating a node here. So creating a node, it is easy, because we are setting here two parameters, I mean two arguments, like a data and none. If we haven't give this, it will take it as none by default, because here we mentioned it. So although I set it here, and we are just making it as head here. So self dot head equal to node of this data. So we are making it as head if it's initially empty. and we are returning because it's the single element we are adding. And the another case which is it's not empty, the linked list has already has some elements. Okay, so in that case we want a temporary pointer like this, temporary variable like this equal to a self dot head. And while this and this not next, which is something, if it's not none, what this is what that means. If this is not none, we are just looping through. So what we are looping is something, we want to iterate through the last of the linked list, and lastly we have to add an element, because add last, the method itself says add last. So if you are having like three elements, 3, 4 and 5 like elements, we want to add this data to, let's take this data as 5. So initially there are two elements, so we want to add this 5 to this linked list. So basically what we have is the head of the linked list, so we want to iterate through this. So iterate through 3 and 4 like that. We want to get this last element, and we have to set the last element's next pointer to this new node. So like this new node need to be set as need to be set into the last node's next pointer, set as. So basically in this example there are already two elements, we have to add 5 to it. So let's say we have to loop through the last of the linked list, we have to loop through until the 4 comes, and we have to change the 4 dot next. Initially it will be null. Okay, initially it will be none. So we have to change that this dot next equal to node of the new data that we have to add, which is 5. So I added this. So this is how it works. So let's see the add friend method. So add friend method is simple. So add friend method will have parameter data, which is we want to pass an argument data because we are adding an element. So basically this is the base case, which is we are incrementing the size by 1 because we are adding an element. And if the data is empty, the same case as here, if the data is empty, we want to set the head to this new node. So the same code goes here, we want to set the head to the new node. And if the data is not empty, we just easily can replace this. Let's take this example as in here. So we have initially 5, 4 and 6 as the elements in the linked list, and we want to add friend the 8th into this linked list. So add friend means it will come here. So what we do is, initially the head will be 5, so we want to change the self dot head as this element, and this dot next will be 5. So the new node is created. So new node with data is 8, and the next pointer will be 5. So initially the 5 will be the head, so next pointer will be 5. So 8 dot next will be 5. So let me replace here. So 8 dot next will be 5. So 8 dot next will be 5, and 8, 5, 4, 6, and it's added, and the new head is 8. So self dot head equal to node of data comma self dot head. So let's take the another method. So in this method we have to remove the last element from the linked list. Let's take this example itself. So we want to remove the 6 from this linked list, and the 4's next pointer will be null. So we have to iterate through the last of the element, the last the second last of the element, second last of the linked list, and we have to remove this. Set this pointer to null. So if the linked list is already none, we can't do anything. So we just return, and we are just decrementing the size by 1. The reason why I am writing here is if the head is none, we cannot decrement it because it's already 0 size. So we are writing here after the base case of checking whether it's an empty linked list or not, and we are setting this pointer to iterate through the linked list, and we are iterating through up to last, second last. So in order to find the second last element, we have to check this dot next equal to none, which means if it's the last element, this dot next is let's take the 4. So 4 for 4 as this. So 4 dot next will be 6, and 4 dot next will be none. So we stopped here by 4. So let's check the next dot next is equal to none. In this case 4 has this case. So let's break here, and we have this pointer as a fourth node, like this node that having 4 as the value, and this dot next equal to that set to be none, because we are just removing this element. Initially this dot next is having this node, like having a value of 6, and we are replacing it by none. We are just replacing it by none. So this is how we remove the last element from the linked list. Let me create this method. Comparatively this looks smaller, and this is an easy method to implement. So it's a remove friend method, like remove friend in the sense, if let's take this example itself, like 8, 5, 4 and 6. So we want to remove the first element, right? We want to remove the 8 from the linked list, and the new head will be 5. Initially the head will be 8, and the new head will be this node that contains the value 5. So what we do is we are just changing the head to the next node. We are just changing the head, we are just replacing the head to the next node. So if it's already empty, we just return nothing, because we cannot do anything if the head is already empty. So we are checking here the data is none, because if it's already empty, we can check the data, it will be none. So and on passing that, if there is an element, we must increment the size by 1, sorry, decrement the size by 1, and we are changing the self dot head to self dot head dot next. We are just changing the self dot head value to the next node by replacing it to the next node. So this is how we remove the front. So we forgot the front, forgot the old head, and we are now in new head. So the data will be 5, 4 and 6. So the 8 has been removed. So let me create the string representation of this function, like a dunder method of the linked list class, so that we can easily see the string representation of this linked list in outputs console. Yes, so this is the string representation. These methods work to give the string representation of the linked list. So if head dot data is none, which means it's empty, we return the linked list is empty. We must produce the return value as string, so that only it will work, because it's the dunder init method. It's a magic method to print. What's the use of this method is we can see we can see the method already, the print of let's say L, it's a list. Let's create a new list, linked list, like L equal to linked list. Yes, let's create this list. So what's the mistake here? Let me check. Yeah, it's the linked list class. Yeah, it's working perfectly. So if we print this, it will produce this string. Okay, so only we are using the dunder init method here. So if we not using the dunder init method, we cannot print like that. Let's say if you are not using the dunder init method like this, and we are giving something like a print here. So how we print is something like we cannot print like this, rather we print like L dot print. Like this only we can print, we cannot print like the normal print. In order to print like a normal print, we have to use the dunder string method. So let me erase it and change this dunder string method. So in order to print like a normal print in Python, we have to use the dunder string method in the whatever the v class we are implementing. So in order to use this instead of this, we have to do that. So let me erase it. Yeah, let me explain this code. And if it's initially none, we have to produce the result as a linked list is empty. We have to return that, and we are keeping, and it's not the case. Let's say it's not the case. There has an element, so we are creating a variable like to maintain our string like result, and we are returning the result at last. And we are first setting the this pointer to iterate through the linked list, and we are checking it's not none, that this is not none. If it's none, we are stopping the loop. So and the result, we are just adding to the result, like concatenating the string to the result, like this dot data. So let's say this example right here. Let me copy that and paste it here for our reference. And it starts like it has 4 elements. We have to print these 4 elements like this, as you see in this screen. And we have 8 and an hyphen and an arrow like this. So only we are using this to separate the values between in the linked list. And we want to we need to have the string representation of the data, because initially it is integer. We cannot concatenate integer to the string to in here. So we have to typecast it into string, and we are adding up another arrow, and we are concatenating it to the result. So like that we are doing as a loop. We are starting from head, like this equal to self dot head, from this equal to self dot head, and we are iterating through the last of the linked list until this. We are iterating, so until this why? Because means if we are stopping here, we we must have another arrow, like it looks ugly, not ugly, but we don't need that. Okay, so let us stop here, like let us check the this dot next data is not none, and we are we are we are out here, and the last element is added here at the end. Okay, return equal to result plus stir of this dot data, which means here this is this node, the last node, and we are adding this data. So it's pretty much clear, I get. Okay, yes, let's type the size. It's actually the easy part, because we are maintaining the size of the linked list. So let me create it by me. And we are just giving the dunder len method as same as the dunder string method, which has a magical work. Like we are using len of if we are creating a list or something else, we can use the len method, right? You may use in basic python programs, use the len method. In order to use that len method, we have to declare it as a dunder len method. Let's say this as the same example right here. Like if you are not giving the dunder len method, we cannot give like this. Instead we can give like this l dot len. So uh, so in order to use the normal method like len of something, we have to declare it as dunder len method. So let me do that again. Dunder len method. Yeah, we get it. So here we just return the size. Even if it's empty, we are returning the 0. So return the size of the linked list, which is self dot size. Yeah, as we are maintaining it already. So let me create some examples and let's check. Okay, yes, we are having these examples here, right here. We are just creating a linked list as l named a linked list object. So l dot add friend, we are just first adding 45 to it and adding last 90 to it, and we are printing l. Okay, let me comment out these. So first let's check if if the first three lines works. So let me comment out this. Yeah, let me run this. Yeah, it pretty much worked. Like we are just adding 45 to it and 90 to it to the last, and it worked. Let's check another code. Like let me uncomment this so that we can check all the items here. Yeah, let me run this whole thing. Yeah, we are having an error. Let me check that. Object of type linked list has no len method. So why it's not having len method? Because yeah, we made a mistake here. The this function is out of the loop, like out of the class. We have it has to be in indentation. Sorry about that. Yes, it's now in indentation. Yeah, let me tab space it. Yeah, it's now in the indentation. So now int object is not callable. So let me write that. So int object is not callable. Wait. So yeah, it's not a function. So it's just an attribute. So we don't need parentheses here. If we are using parentheses, it must be a method or a function. So here we need no need parentheses. As it is just an attribute. So let me run it again. Yeah, it works perfectly. See, if you are practicing, we may get more errors. In order to solve out those errors, that's the basic idea behind learning. So we can easily learn or develop anything by solving errors. So these are very simple errors. If we check the code again, we can easily get it. So it makes us experienced guy in developing or programming. Yeah, let's check the example. So we are first adding a 45 to it and 90 to it. We are just printing it. The first line is this lines, the 64th line, and we are adding 67 at last. We are adding 67 at last and 78 at front. Yeah, front 78 and 67 at last. We are printing again, and we are remove the front. Remove the front means the 78 is gone. So 78 is gone. So and print it again. So we can see that 78 is only gone. And we are printing the length of the linked list, which is 3. So here you can see the 3 elements, and we are removing the last at the last step. So we are having the 2 elements left after 67. So we can see it's easy. So please try it and practice it. So thanks for watching. If any suggestion, please comment it below. Yeah, see the description for the code. I have linked it through GitHub. So thanks for watching. Come back again.